In the world of cybersecurity today, just being reactive, well, it's simply not going to cut it anymore. The threats are just getting way too smart, way too fast. So how do you possibly prepare for an attack you've never even seen? Well, you build yourself a digital sparring partner. Okay, let's dive right into this explainer on Netlab, a tool that's all about creating a virtual battlefield where you can really test your defenses against some seriously realistic, simulated threats.
All right, so here's our game plan. First, we're going to survey the modern cyber battlefield to see why the old ways of training just aren't working. Then we'll introduce a new kind of lab. From there, we'll get hands-on, building a digital twin of a network, unleashing some controlled attacks, and then, of course, figuring out how to strengthen our defenses. And finally, we'll wrap up by looking at what this all means for the future of being prepared. Okay, let's kick things off by setting the stage. The cyber battlefield has gotten huge. I mean, unbelievably big. And the training grounds we used to rely on, they're becoming obsolete, fast. Look, there's no way to sugarcoat this, and it's a hard truth. Your network is a target. With this absolute explosion of new devices, cloud services, and super sophisticated attack methods, every single network out there, from the smart fridge in your kitchen to a massive corporate headquarters, is a potential target. The attack surface has never, ever been larger. And what's really wild is just how diverse these threats are now. We're not talking about simple computer viruses anymore. We're dealing with massive botnets made up of insecure smart toasters and cameras, malware that literally evolves to avoid being caught, and attacks targeting everything from our home routers to critical industrial systems. The bottom line here, our old security playbooks just can't keep up with this stuff. So this brings us right to the heart of it all. We need a totally new kind of lab. If the threats out there are dynamic and always changing, our training environment has to be too. And that, right there, is where Netlab comes in. I absolutely love this analogy because it just hits the nail on the head. Think about it. Pilots train for thousands of hours in flight simulators, right? They experience every possible failure, every emergency, all in a totally safe environment. Why on earth should network defenders be any different? Netlab gives us that exact same thing, a realistic, controlled space where you can practice, you can make mistakes, and you can learn without any of the real-world consequences. So what is Netlab, really? Well, think of it as a tool that lets you build a perfect digital copy of a network. But it's way more than just a static model. It's a living, breathing environment where you can spin up complex networks with equipment from all different vendors, even IoT devices, all so you can safely poke and prod for weaknesses. And wow, when you put them side by side like this, the difference is just night and day. Old school labs were rigid, static, and usually focused on just one vendor's gear, which, let's be honest, isn't realistic at all. And they took forever to set up. Netlab just flips that whole script. It's dynamic, it's flexible, it lets you model real threats across tons of different vendors, and you can spin up a complex lab or tear it down in minutes. It's a huge, huge leap forward. Okay, so you're probably thinking, a network flight simulator sounds awesome, but how do I actually build one? Well, it's probably more straightforward than you imagine. The whole process kicks off with creating what we call a digital twin of a real network. It really boils down to 3 simple steps. First, you just identify what you want to build. Which routers, which switches, maybe some servers or IoT gadgets. Second, you write it all down in a simple file called a YAML file. You can think of it like a recipe or a blueprint for your network. And third, you just run a quick check to make sure your blueprint doesn't have any typos before you hit the big build button. All right, so once your blueprint is ready, you've got a couple of options for actually deploying it. If you need something lightweight and scalable that you can create and destroy really fast, Container Lab is going to be your best friend. But for those super complex simulations that need the raw power of full virtualization, you can use KVM. The key is you've got the right tool for the job, no matter what it is. And now we get to the really fun part. You've built your digital twin, so it's time to see how well it holds up when things get rough. This is where you put on your attacker hat and start launching some controlled attacks to see what breaks. This right here is the guiding principle for all red teaming, for all ethical hacking. It's so fundamental. You just can't effectively defend against an enemy if you don't understand how they think and how they operate. By simulating these attacks, you get this priceless insight into how a real adversary might move around inside your own environment. So, what kind of trouble can we stir up in this safe little sandbox? Oh, all sorts. You can generate the insane chaotic traffic of a botnet to really stress test your systems. You can intentionally add a common mistake, like a lazy firewall rule that leaves a door wide open, just to see if your alarms actually go off. Or you can model how an attacker, once they get inside, could start hopping from machine to machine. It's all about finding the holes before the bad guys do. Okay, so we've played offense, we've found the cracks in the armor, now it's time to flip the script. All that data, all those insights you gathered from your attacks, now you use them to test, validate, and seriously harden your security. And this is where the rubber meets the road. All those theories about your security, now you can actually prove them. Are your firewall rules really doing what you think they're doing? Does your network segmentation actually stop an attacker from spreading? Netlab lets you answer these questions with hard data, not just guesswork, because you can capture and analyze all the traffic during these simulations. And this right here, this is the whole point. It's a continuous loop that leads to real cyber resilience. You create a safe space to test things out, you capture the results, you analyze what went right and what went wrong, and then you adapt your defenses. The best part? This all happens on your schedule, not an attacker's. Okay, so let's zoom out for a second and look at the bigger picture. This whole approach isn't just about one cool tool. It's about a massive shift in how we think about cybersecurity, and it has huge implications for everyone's career and for the entire industry. I mean, just look at what's coming down the pipe. Every single one of these trends, ransomware, adaptive malware, complex cloud networks, they all demand a more dynamic and realistic way to test our defenses. And by using what's called infrastructure as code to build these labs, it means our training can evolve just as fast as the threats do. This is how we stay ahead of the curve. And really, that's the one question I want to leave you with. We know for a fact that the bad guys are practicing. They're refining their tools, they're testing their malware in their own labs. The only way we even stand a chance is to do the exact same thing. So the question is, are you ready to build your flight simulator?